Hello everyone. Thank you so much for coming tonight for our first AI talk. We are really proud to do this first event. We worked really hard with all the team to make this moment possible. You have Adrien and we, which are here. There is also Min and Valentin, which might have let you come in. And there is also Victor and Chloe, which I don't know if they were able to arrive yet. And so this is from the work that's possible. And we will start the event with first Stanislas, which will talk to us about the legal impact of AI. We'll then have Sergei, which will show you how to train and fine-tune your model. We'll then have Charbel tell us a bit more about AI safety. We'll have Datacraft, which will tell you about their institution. And we'll finish with Firas on prompt engineering. With that, let's hear Stanislas on the legal implication of the AI Act and RGPD.
Hello everyone. Thank you, Louis, for the presentation. So I'm going to do the presentation in French, but the slides are going to be in English. And if you have any question, we'll be glad to answer in English or in French. But I want to be the most precise in the legal terms, so I'm going to do it in French. Ouais, donc, je suis vraiment ravi d'être ici. Donc, moi, j'ai fait ma thèse sur le règlement IA, dont vous avez sûrement tous entendu parler cette année, que j'ai suivi pendant 4 à 5 ans, notamment sur la question des risques et des droits fondamentaux. Et c'est bien, c'est la première fois que je présente un peu une partie de mes recherches, disons, au monde professionnel. Ça me fait un peu sortir de ma bibliothèque, donc c'est très bien. Ouais, c'est vrai que c'est pas le bon truc. Donc, pour rapidement commencer, donc le monde, disons, du droit de l'IA a énormément évolué depuis 7 ans. Quasiment, bon, encore moins vite que la technologie elle-même, mais de manière assez exponentielle, en tout cas depuis 2018. On a eu une explosion des normes, qu'elles soient, disons, de droit souple, ça veut dire des chartes, des labels, ce genre de choses, ou en tout cas, ou alors du droit dur, donc des règlements européens. Donc on a vu le DMA, le DSA passer sur des questions algorithmiques, et donc récemment le règlement IA. On a eu aussi le fameux traité du Conseil de l'Europe, mais ça on y reviendra assez rapidement. Donc on a eu une explosion de normes pour le secteur professionnel de l'intelligence artificielle, et ça se traduit par aussi une augmentation forcément des coûts pour les jeunes entreprises. Donc, pour rapidement, on n'a pas le temps en 10 minutes, bien sûr, de revenir sur chaque norme et sur chaque réglementation qui ont apparu depuis 7 ans, mais moi, quand j'ai commencé ma thèse, il y avait à peu près 400 chartes, ou en tout cas livres blancs, ou de droits souples qui étaient apparus, et je suppose que ce chiffre a encore augmenté depuis mai 2024. Donc ça fait énormément de labels, de normes à vérifier, et si on rajoute à ça les 2 derniers... en tout cas le traité européen, le traité de l'Europe plus le règlement européen, ça fait énormément de choses à vérifier pour les entreprises. Alors, pour, disons, un peu couper dans le gras, la première chose, c'est il faut bien faire la différence entre tout ce qui va être chartes d'entreprise, même si elles ont forcément une implication juridique ensuite, si jamais pour des questions de responsabilité, et tout ce qui va être proposé, en tout cas auprès de l'Union européenne, ou qui va sortir d'une assemblée législative. Donc, si jamais, donc, mon conseil pour les entreprises, c'est de vraiment focus sur les questions de réglementaire, donc notamment le règlement IA qui est aujourd'hui en service depuis août 2024, donc qui rentre en service ensuite entre 6, 9, 12 et 36 mois, selon les différentes obligations. Et bien évidemment sur le RGPD, notamment pour les questions de fine-tuning, mais ça on y reviendra dans 2 minutes. Donc le RGPD et le RIA, ou le AI Act. Donc le RGPD, vous y êtes tous confrontés depuis maintenant quelques années, donc, en tout cas depuis 2018. même s'il est rentré en service en 2016. Et le règlement IA, vous y serez de plus en plus confrontés tous les jours dans les prochains mois qui viennent, notamment si vous travaillez dans certains domaines, notamment je pense aux domaines qui sont considérés comme high risk, ça veut dire par exemple la santé, le travail ou la biométrie, ce qui peut être le cas ici. Sachez que la plupart, c'est entre nous, mais la plupart des entreprises aujourd'hui ont peu de cas considérés comme high risk. C'est-à-dire que moi j'ai travaillé pendant longtemps pour une entreprise, un grand groupe industriel des télécoms. Dans tout le recensement qu'ils avaient fait, ils en avaient recensé que 2. Pourquoi? Parce que tout le monde ne travaille pas dans la réglementation du règlement IA fonctionne en fonction du cas d'usage. Ça veut dire que peu importe le système, enfin pas peu importe le système, mais en tout cas, si jamais vous ne travaillez pas dans un secteur spécifique, vous allez être confronté à moins d'obligations. Donc c'est un fonctionnement de la même manière un peu que le RGPD, un peu pyramidal, donc c'est une approche par les risques. Donc si vous travaillez par exemple dans le domaine militaire ou de la police prédictive, ce sont des systèmes d'intelligence artificielle qui risquent d'être interdits d'ici à 2025. Si vous travaillez dans le domaine de la santé ou du droit du travail, ou en tout cas juste RH, vous serez confronté à des obligations high risk et ensuite vous devrez déterminer votre place dans la chaîne de valeur de l'IA, mais ça on y reviendra. Donc en gros, qu'est-ce que ça veut dire ? Rapidement, ça veut dire que si jamais vous êtes fournisseur d'un système d'intelligence artificielle ou si vous êtes distributeur, vous n'aurez pas forcément les mêmes obligations en fonction du cas d'usage. Le dernier, donc, c'est le traité du Conseil de l'Europe. Mais alors le traité du Conseil de l'Europe, vous en avez peut-être entendu parler, il est passé il y a quasiment un mois. Mais on ne va pas revenir dessus, puisqu'en termes d'applicabilité juridique, il y a peu de chances qu'on voit les obligations qui sont attenues à jour arriver en France. Pourquoi ? Parce que les États-Unis et l'Union européenne en fait, ont tué le traité dans l'œuf, dans le sens où ils ont obligé le Conseil de l'Europe, donc qui est le Conseil qui est en charge de la gestion des droits fondamentaux pour toute l'Europe, enfin l'Union européenne plus d'autres pays, notamment Israël, les États-Unis et d'autres, et qui sont d'ailleurs pas dans l'Union, qui sont pas dans l'Europe. Et en fait, ils ont tué le traité dans l'œuf en précisant que ce traité serait à la main des États pour l'applicabilité dans le secteur privé, donc il s'adresse avant tout au secteur public. Et deuxième point, c'est que l'Union européenne a précisé que l'application du traité se ferait au travers du règlement IA pour l'Union européenne. Donc, d'abord le RGPD. Donc, le RGPD, il y a plusieurs choses à entendre. Donc, bien sûr, l'article 22, qui est celui qui est relatif aux décisions automatisées. Donc, le RGPD, vous en avez tous entendu parler, vous commencez à bien le connaître. En tout cas, vous commencez à connaître les procédures qui y sont attenues. Mais, alors il faut savoir, et ça peut être un peu la bible des startups en matière de RGPD et de fine-tuning, ça va être les recommandations de la CNIL. En fait, la CNIL, il y a quasiment 6 mois, a lancé de grandes consultations auprès des entreprises pour comprendre comment fonctionnait réellement l'intelligence artificielle et surtout comment fonctionnaient les processus pour les données personnelles avec l'intelligence artificielle. Et ils en ont sorti à peu près, je crois qu'on est maintenant à 10 fiches sur l'IA, donc je vous recommande tous d'aller les vérifier. En termes, je sais que la réglementation a un coût pour les entreprises, estimé à peu près à 10% pour une start-up, du CAPEX, ce qui peut faire énormément d'argent et qui peut même tuer certaines start-up dans l'œuf. Mais en tout cas, ça, ce sont des ressources qui sont gratuites et vérifiables par tous. Et ça permet de se mettre en conformité de manière plutôt simple, surtout que la CNIL est quand même une autorité administrative qui écoute avant de sanctionner, généralement. Et donc on peut lui poser ses questions, il y a des standards, et on peut comprendre ses fiches. Donc ces fiches, qu'est-ce qu'elles disent notamment pour la question du fine-tuning? Donc l'IA, elle part un peu du principe que si vous faites de l'IA, si vous utilisez des systèmes d'IA, il y aura quasiment, en tout cas la plupart du temps, des données personnelles. Donc en fait, si jamais vous entraînez, vous réentraînez un système d'IA, la CNIL va considérer que c'est un nouveau traitement de données personnelles. Ça veut dire que si par exemple vous avez une brique d'IA, ou en tout cas vous utilisez un modèle qui a été fourni soit depuis l'étranger, soit par une autre entreprise, et que ces finalités n'ont pas été définies clairement, par exemple, il était expliqué dans ces finalités que ce modèle devait utiliser à la langage, à la vision, à la gestion d'images, ce genre de choses, mais que vous avez trouvé une toute nouvelle façon d'utiliser ce modèle, et vous en avez fait un système qui, par exemple, est applicable sur des questions de santé. Eh bien, vous allez devoir recommencer absolument tout le traitement de données personnelles. Ça veut dire que vous allez devoir trouver une nouvelle finalité, une nouvelle base légale, qui peut être le contrat, ou en tout cas l'intérêt légitime, Vous allez devoir, bien sûr, prévenir les personnes qui ont été en amont prises dans le web scrapping, ou en tout cas qui ont été prises en amont de l'entraînement de la première phase du modèle. Et ensuite, vous allez devoir vous-même être extrêmement transparent et assurer les droits des personnes, donc le droit de rectification et ce genre le droit d'opposition. Donc en fait, ça peut être extrêmement lourd. Donc le conseil que je peux vous donner, en tout cas en matière de fine-tuning avec le RGPD, c'est de conserver et de forcer, en tout cas que ce soit même de l'open source, même si aujourd'hui c'est de l'open weight, et ça on peut en débattre, mais en tout cas de conserver la documentation qui est fournie par les grands producteurs de modèles d'IA, aussi de forcer les entreprises sur qui vous avez trouvé vos premières briques, de conserver toute la documentation relative au RGPD, puisque c'est quelque chose qui pourra vous être demandé dans un deuxième temps, et ensuite de vérifier que dans ces documentations, la finalité pour laquelle vous avez réentraîné ce système est précisée, sinon vous allez au-devant de lourdes charges réglementaires supplémentaires. Donc, bien sûr, le deuxième règlement, alors il faut savoir que le RIA, enfin le règlement IA, le AI Act, et le RGPD fonctionnent un peu comme des frères et sœurs. Ça veut dire que si vous êtes face à un système high risk, la CNIL va toujours considérer que vous allez devoir, par exemple, faire des Data Privacy Impact Assessment, ça veut dire que des AIPD, donc vous allez devoir, de toutes les façons, vérifier la question des données personnelles dès que vous êtes sur un système considéré comme à haut risque. Donc la timeline, c'est 6 mois pour les pratiques interdites, 9 pour l'application des codes de conduite. Alors l'application des codes de conduite pourrait être un peu dedans, le temps que toutes les entreprises se mettent d'accord, on n'est pas forcément sûr que ça arrive pour avril 2025, mais bon, on ne sait jamais. Ensuite, on a au bout de 12 mois, donc on aura la question des IA à usage général. Donc l'Union européenne, comment est-ce qu'elle traite la question des IA à usage général? Elle le fait en termes de flop, donc on est autour de 25 flops, donc je crois que c'est à peu près aujourd'hui l'AMA 3 ou ce genre de choses. Et même si aujourd'hui on voit en fait un comportement un peu déviant, c'est qu'on voit des gros producteurs de modèles d'IA se mettre juste en dessous de la réglementation pour éviter toutes les questions de transparence qui sont liées. Et ensuite, bien sûr, au bout quasiment de 30 mois, on aura les obligations pour les systèmes à haut risque. Alors oui, c'est une réglementation qui va mettre du temps à se mettre en route. On n'est même pas sûr qu'elles sont encore pertinentes, pour être tout à fait honnête, dans quasiment plus de 2 ans. Mais bon, ça c'est un peu le rôle du droit qui court toujours derrière l'innovation. Alors, ce que j'avais précisé, le plus important avec le règlement IA, c'est aussi de déterminer votre chaîne de valeur, donc votre place dans la chaîne de valeur. Pourquoi? Parce que imaginons que vous êtes, disons, provider d'un système, ou en tout cas qu'une entreprise vous a fourni un système et que vous avez décidé, par exemple, de faire du fine-tuning dessus, donc de le réentraîner. Si jamais vous l'avez fait de manière à changer de manière substantielle la finalité du système, vous allez devenir vous-même provider. Et donc, en devenant provider, ça fait énormément de documentation en plus à fournir, à conserver et à transférer sur tout le reste de la chaîne de valeur de l'IA, donc jusqu'au distributeur et à l'user, pour qu'elle soit disponible et que ça reste transparent. Donc il faut faire attention à la place que vous avez dans la chaîne de valeur. Et donc il y a plusieurs choses. Si vous apposez votre marque sur un modèle qui est déjà existant, pareil, vous passez provider. Donc la définition de modification substantielle, elle est très large. Donc on peut être sûr quasiment que quasiment dès que vous faites du fine-tuning, vous passez aujourd'hui provider. Et ça, les grandes boîtes américaines, elles l'ont très bien compris. C'est pour ça qu'en plus, ils font de l'open source pour se mettre en dehors du scope du règlement IA. Même si aujourd'hui, ils font de l'open weight, ça veut dire qu'ils ne donnent pas vraiment toutes les informations. Mais disons que la commission ferme un peu les yeux, même si c'est un comportement relativement déviant. Mais du coup, la réglementation pèse sur les petites entreprises aujourd'hui sur l'Union européenne. Et la troisième chose, ça va être de déterminer le niveau de risque. Donc il y a des checkers qui sont disponibles en ligne, si je sais que ça a un coût aussi, mais il y a des checkers qui sont disponibles en ligne, notamment celui du Institute for Life, qui permet assez rapidement de savoir le niveau de risque et de déterminer le niveau de risque de mon système d'IA. Et enfin, j'ai fini, c'est très bien. Donc se préparer, savoir sa place dans la chaîne de valeur, déterminer son niveau de risque et faire attention à la question de la modification substantielle. Voilà. Donc, merci à tous pour votre attention et je crois que j'ai respecté à peu près le temps. Ça va, j'ai un peu dépassé. Voilà. On dit. Voilà. Il y a des questions, c'est ça?
Je vais commencer.
Ouais.
Merci. Si jamais j'ai un petit LLM que je souhaite fine-tune sur, par exemple, quelques centaines d'exemples pour la classification, qu'est-ce que je devrais prendre comme action concrète pour me mettre en compliance avec l'AI Act?
Ouais, alors est-ce que tu peux me préciser ton petit LLM, tu l'as trouvé où?
Un LLM open source qui est dispo, par exemple, 𝗔𝗜 de Google.
Ouais. Eh bien alors, s'il est open source, tu peux être sûr que... Bon, ça veut dire que la documentation, elle est disponible normalement, même si, c'est ce que j'ai dit, ils font un peu le point. Donc cette documentation, tu dois la conserver pour être sûr de pouvoir la fournir ensuite aux personnes. Après, ça dépend, est-ce que c'est pour une utilisation personnelle ou c'est pour une utilisation professionnelle?
Pour une utilisation commerciale. En tant que startup, je viens le fine-tune, ce modèle open source, pour l'utiliser sur mes cas d'usage.
Voilà. Parce qu'il y a des out of scope, hein, je précise, si jamais vous faites de la recherche scientifique ou que vous faites des trucs direct seulement dans votre chambre, bien évidemment, vous n'êtes pas soumis à la réglementation. Mais donc là, pour une utilisation commerciale, donc tu vas devoir conserver toute la documentation qui est disponible, qui est donnée par Google. Et toi, de ton côté, tu vas être considéré comme, celui que tu vas fine-tune, tu vas être considéré comme provider. Donc là, tu vas devoir, il y a des questions de transparence, notamment sur le poids de modèle, sur la question des capacités, sur la finalité, c'est-à-dire ce que tu vas faire avec, sur les atteintes peut-être, si jamais c'est considéré, tu l'utilises dans un cas high risk, ça veut dire que si tu l'utilises par exemple pour faire de la classification dans le domaine de la santé, dans ce cas-là tu vas devoir faire ce qu'on appelle un Fundamental Impact Assessment. Alors on n'a pas encore exactement les normes, parce que le RIA dépend énormément des normes qui sont en train d'être négociées au sein de l'Union européenne, et donc par exemple déterminer pour une entreprise dans les cas de droits fondamentaux elle-même, qu'est-ce qui relève des droits fondamentaux ou pas, ça peut toujours être un peu problématique. Mais du coup, tu vas devoir donner énormément d'informations aux distributeurs qui sont derrière et aux final users. Et ça, donc, c'est les capacités du modèle, c'est les finalités, c'est les données avec lesquelles tu as entraîné. Et voilà, il y a un tas d'informations à donner. Et à conserver, bien évidemment.
Ok, très bien, bah, merci.
De rien.
Est-ce qu'il y a d'autres questions?
Okay. Merci pour le talk. Au début, tu as dit que l'applicabilité de ces règles dépend du domaine d'activité.
Ouais, non, c'est pas ça. C'est qu'en fait, en tout cas pour le règlement IA, le cas d'usage dépend, oui, foncièrement, en fait, donc du cadre dans lequel tu vas l'utiliser. Par exemple, si tu utilises un système d'IA dans le domaine du forecasting, ou un CRM client, mais qui est par exemple celui de la gestion de vêtements, bah, la question du risque va être beaucoup moins importante que si tu l'utilises dans le domaine de la santé ou de l'éducation, ou que ton système d'IA est utilisé à côté d'enfants, ou ce genre de choses. Voilà.
Et du coup, ma question, c'est si moi je ne suis pas dans le domaine de la santé,
ouais.
mais mes clients le sont,
oui.
Est-ce que les modèles que moi je fournis sont soumis à ce genre de réglementation ou pas?
Mais alors, c'est une très bonne question. Disons que tu es une entreprise A. Mais est-ce que tes clients vont modifier ensuite non. Donc ça veut dire que c'est prévu dans les finalités de ton modèle, enfin de ton système, qui puisse être utilisé, par exemple, dans le domaine de la santé.
Oui.
Et bien à ce moment-là, tu tombes dans les questions de high risk. Parce que si jamais tu étais une entreprise qui n'avait pas prévu cette finalité-là, tu vends des modèles, des systèmes, disons, un peu généraux, et c'est une entreprise derrière qui l'adapte spécifiquement pour les questions de santé, là tu vas être considéré comme provider aval, et en fait tu auras moins de documentation à fournir, tandis que l'entreprise à qui tu as vendu le modèle, ou en tout cas qui s'est fourni chez toi, lui sera considéré comme le vrai provider et aura énormément de documentation à donner aux distributeurs derrière. Ouais.
Okay. Et question subsidiaire,
ouais.
Si mes clients ne sont pas basés en Europe, est-ce que la question...
Ça dépend. Ouais, alors il y a plusieurs choses. Est-ce que tes clients font du business avec des Européens? Est-ce que ça touche? Ça peut aller très loin. Est-ce que le système peut être utilisé dans une ambassade de l'Union européenne, sur un bateau avec un drapeau européen? En fait, à partir du moment où tes clients ont une quelconque utilisation commerciale vis-à-vis de l'Union européenne à un moment et que ton modèle d'IA est utilisé pour ça, alors il tombe dans le scope du règlement IA. C'est le même principe que le RGPD. Si jamais c'est à destination à un moment d'une personne qui est citoyen européen, alors à ce moment-là, on est dans le scope du RGPD.
Ok, merci.
De rien.
une autre question, il me semble. Ouais.
Celui-là. C'est le micro. Oui, bonjour.
Bonjour.
Je développe une IA mais donc basée sur l'Oracle de Google.
Ouais.
Pour le développement de la fonctionnalité des protéines. Donc j'utilise énormément de données scientifiques, donc aucune donnée personnelle mais des données scientifiques. Et toutes les données scientifiques que j'utilise, j'ai des contrats d'utilisation. C'est-à-dire j'ai des contrats d'utilisation avec l'Université de San Diego, avec la Caroline du Nord, avec l'INRAE, etc. Donc il n'y a aucune donnée publique pour l'instant. Et l'outil restera toujours chez moi parce que je ne mettrai jamais à disposition l'outil, mais j'aiderai les entreprises à améliorer leurs fonctionnalités. C'est-à-dire, ça sera un service que je vais rendre, mais jamais mon LLM ne sera en possession de mon client.
D'accord.
Est-ce que là, on tombe sous le RGPD ou pas?
Alors, c'est une question, bien sûr, vu que c'est une réglementation jeune, chaque cas d'usage ou chaque personne chaque cas est plutôt spécifique et le vôtre l'est particulièrement. Alors, est-ce que, par exemple, vous m'avez dit que vous travaillez avec des universités, est-ce que vous considérez, est-ce qu'il y a une activité de recherche scientifique derrière? Qu'on peut considérer de recherche scientifique?
Oui.
Eh bien, dans ce cas-là, vous seriez out of the scope. Après, ça dépend aussi de l'utilisation. Par exemple, si l'INRA développe un système d'IA et qu'il ne le propose pas à des entreprises derrière, en tout cas qu'il n'est pas utilisé, alors il va falloir en tout cas préciser la question de service que vous rendez aux entreprises, bien évidemment, mais si jamais ça reste uniquement de la recherche en interne, du développement avec l'université, là, pour l'instant, vous êtes en dehors du scope du RIA, et d'ailleurs, vous êtes aussi pour pas mal, en tout cas du RGPD, vous êtes aussi out of the loop de pas mal d'obligations. Mais à partir du moment où vous allez proposer vos services à des entreprises, là, il faudrait regarder spécifiquement, mais il est possible qu'on retombe sur des questions commerciales. Mais disons que tant que ça reste chez vous, ou alors du côté de l'université, là, on est vraiment sur des exceptions high risk. Donc il y aura forcément peut-être des questions de transparence, mais donc il y aura forcément des questions de transparence. Après, je ne peux pas vous dire comme ça sans avoir vu les contrats ou même la relation exacte que vous avez avec les entreprises, si jamais vous retombez sous le scope du RIA.
D'accord.
Voilà, je suis désolé.
Bon, merci beaucoup pour cette présentation.
Juste une question c'est l'outil pour déterminer le risque du système d'IA.
C'est la dernière question.
L'outil pour déterminer?
Oui, exactement.
C'est celui de l'Institute for Life. Life Institute. Ou sinon, je te tape le lien juste après, mais je ne sais plus si c'est Institute for Life ou Life Institute. Mais en tout cas, ils ont développé un checker en ligne gratuit et il est plutôt bien fait. Donc il faut en profiter. Voilà. Merci de votre attention.
Merci.
Merci.
Super.
A long time ago, I was a baby. And when I was a baby, I didn't know how to do much. I didn't know how to speak. I didn't know how to read. I didn't know how to write. But what I did know is that there are a lot of things I can learn. And so I went to school. I went to school. There I was forced to learn a lot of things. I was forced to read a lot of books. I was forced to do mathematics and physics. But ultimately, I decided to do programming. And I specialized in it. And here I am today. But if we look a little bit closer, what is the difference between those two pictures? On the first one, we see a boy. A pretty boy, I must say. But the boy who barely knows how to read, who barely knows how to write, and who barely knows how to speak. And on the second picture, we see a person who specialized himself in the technology and programming. And so I think the thing which separates those two pictures is training. And the same goes to LLMs, which we're using right now. You can start using any LLM out of the shelf. It can do a lot of things. It can do basic things, maybe a little bit advanced things, but probably it would not excel at your use case. And to do so, you need training. And so today, in my speech, I'm going to be talking about how to train the AI model you need. Before we start talking about how to train the model, we need to understand why and when do we need to train the model. So you all know that, like, you use GPT, of course, and sometimes you ask it the questions. And you know that sometimes the GPT is really good at answering your question. Let's call this problem a simple problem. So let's say you ask GPT a question and it is consistently right. Well, good job. You don't need to fine-tune the model. You're already there. Now let's imagine the problem is a bit more difficult. So you ask the model a questions, and sometimes it's right, sometimes it's not. Ultimately, you're not happy. So what do you do next? For example, you can start improving your prompt. You can write a more detailed instruction. You can ask the model to think. You can say that it's very important, otherwise I'm going to get fired. And ultimately, you can do a lot of prompt engineering. But sometimes this is not a solution. So I want to share my experience here. We needed to get the highest performance possible from the model. Initially, we wrote a prompt. And to run the entire data set and label it with the model, it costed us $5. But as I told you, we wanted to get the highest performance possible. And so what we did is we started improving the prompt. So we added some examples into it, we added clarification, and ultimately the prompt became better, and the model started getting 5% more accurate. However, the problem is here. For those who don't see, the price increased by 16 times. And so sometimes when you see this, you get a little bit demotivated. But for this, there is a solution which is called fine-tuning. Ultimately, it allows you to decrease costs because you don't need to have a really big prompts which detail every case, but rather you let the model learn the behavior through observing the data. So this is to counter this example. And also, let's say you had a model and you fine-tuned it. Ultimately, the model became better. So if you were satisfied with the initial performance, what you can do is you can take a smaller model and fine-tune it. And having a smaller model is really beneficial. It's much cheaper to host it, and it's much faster. So ultimately, if in your application you care about speed and costs, you should also think about fine-tuning. So today, we're going to fine-tune the model. No surprise. But we're going to fine-tune a special model. You all know that around a year ago, we got two exciting events. First of all, there was a guy who came out of nowhere, and he said that I have the best open source model. And he said that it was the best one because it can truly reason. Well, some people trusted him, but ultimately it was a big lie. It was a fake. But then GPT-01 released, the model who can really reason. And so today, we're going to do something very difficult. In 10 minutes, we're going to train the model who can reason too. I don't know. It would reason. I don't know if it's going to be saying good things, if it's going to be intelligent or not, but it would try to reason. And so this is what we're going to do right now. No. Okay. So, of course, we can be very ambitious. We can start writing a really great scalable pipelines from the day one. But I think that here we're talking more about prototyping. And when prototyping, we need to be smart and efficient. And so for this reason, I chose a library which is called unsloth. So this is a library which is really good for the first prototypes. What I mean is that it allows you to do your fine-tuning fast, it allows you to do it cheap, and it allows you to do it without too much work. So setting up the entire model training process can take only a few hours. And it's going to give you a good enough results for you to understand if you want to invest more time into it or you're already happy. So let's look at what's happening a little bit. So here, I'm preparing to download a model. This is a model which is called Llama. It's an open source model, so I guess it has an instruction. It has a manual, so it's good. Yeah, it has 3 billion parameters, and it's called instruct. So let me just quickly explain what this means. So when you're just starting prototyping your application, you don't need to choose and start from the biggest model. You can start from a good enough model, and then if it works, you can decrease the size, or if it doesn't work, you can increase the size and try to use a bigger model. And so here I'm starting with a small enough model, but the one which would give me some understanding. So if you're doing something very difficult, you should probably start with a model of 7, 8, or 9 billion parameters. But here, just to be quick, I'm going to be starting with a smaller model. And the another thing is that I told you it's instruct. What this means is that there are two kinds of versions. There is an instruct model and there is a base model. The instruct model is specifically designed to follow instructions. So just like when you use GPT, you ask it a question, it responds. Well, apparently there are some models who are a bit worse at it. And so for 99% of your use cases, if you don't have a lot of data, you should use instruct model. So this is what we're going to do. Here, I want to pay your attention that we are taking the model and we're downloading the pre-trained model. But what's interesting is that we're not getting just the model. We're getting the model and the tokenizer. And so you can ask me, what is the tokenizer? Right now I'm looking at you. I have my eyes. They're making like a screenshot, but they don't understand what's happening. And this screenshot goes into my head, into my brain. And so you can look at this way. So the tokenizer, in fact, is like my eyes. It prepares an input for the brain. And in this case, the brain is the model. I give a really clear example here. Let's say we have a sentence. Then the tokenizer can be something which would, for example, split the sentences and split the words and encode them in some way. So ultimately, it's just a kind of important device which would process the data before giving it to LLMs. Yeah, I promised you that we're going to train the model which would be able to reason. But firstly, let's see what are we going to do? What are we going to be doing? So here, I decided to choose a data set. The data set of question answering problem. So there's going to be a question, and we need to choose an answer. So in this case, this is more like an academic benchmark, where we have a question with some blanks, and we need to choose an option which says which answers are correct. And so this would be the goal of the model. And ultimately, what I ask the model to do is I ask to say which letter is correct, and when it says that the certain letter is correct, it should indicate it with the phrase the answer is X, where X would be the character of the correct answer. And so I told you that sometimes you don't need to train your own model. First, you need to understand if your model is not already good enough on this problem. So what we're going to do here is that we're going to evaluate our model. There are 24 examples. What we're going to do is we're going to patch each of those test examples, and we're going to see what model thinks about it. Then, as I told you, I asked the model to say the answer is and the character. And so here, what I'm going to do is I'm going to find the phrase the answer is, and then I'm going to get the first character out to scrape the answers of the model. And this 16% accuracy is the moment where the things start going wrong. So 16% is about as good as if I was given a random answer. So it's a very bad result. Basically, it's like tossing a coin. It doesn't mean anything. And so at this point, we start investigating what is wrong. And so if I were to see what my model outputted, actually, it didn't output most of the time anything meaningful. So normally, when we're talking about test questions, I ask the answer to be a capital character. Well, here you see some of them are math symbols, some of them are lowercase characters. So ultimately, there is something wrong. And if you look a little bit closer, we'll see that most of the time, for example, here or here, the model doesn't say anything what we asked it to do. And so this is the moment where I stop and I make a really important disclaimer. when you're doing any application in artificial intelligence, it can be an LLM-based application, it can be any other application, you should really focus on the data. So far, we're not fine-tuning the model, but we have a prompt, and this prompt clearly doesn't work. We have the data processing algorithm, which takes an output of the model. This algorithm also clearly doesn't work. And so this is the moment where you stop, you really improve your prompt, you rethink everything you do, because even if you get the best training data possible, chances are it's still not gonna work. So if you have one thing to remember from my speech, for any AI application you do, you should really focus on the data and the way you're handling it. Okay. So, but just for demonstration, we're gonna keep this data. It's still not gonna be great, but we can continue. And so I told you that the model would be able to reason. And to train the model, normally we don't need just a question. We also need an answer. And so here we have an example of the data we're going to be training it on. So the same example, the same answers, but in the end, we prompt the model to reason. So we say, let's think step by step. Then the model is thinking, and then ultimately we finish our answer with the phrase, the answer is, and the correct character. And so on this data, we can train the model, because right now we have a reasoning process, and ultimately our model, the goal of the model would be to replicate it. So we start training the model here. When I'm doing mathematics, when I'm learning a new theorem, I'm not starting from scratch every time, but rather my theorem is the logical continuation of everything I learned before. So a new theorem is just a dependency, is dependent on a few other theorems I knew. And so to learn a new theorem, I don't need to start from scratch. What I can do is I can take part of my knowledge and slightly change it. And so when you fine-tune the model, you do something very similar. You have an initial model, and you have a subset of parameters you want to update. And this is the way we're going to be fine-tuning the model, and this is ultimately the way you should start with, because it's very fast, it's very cheap, and it's very easy to set up. This methodology is called LoRa, and you probably heard this name before. So here I'm setting it up. Nothing difficult, but there's one important parameter, r equals 16. So it just indicates how many parameters are we going to be fine-tuning and how many are going to be fixed. So the bigger the number is, the more parameters we would be changing. And ultimately, when you're just starting out, it's better to have it set to 16, 32, or 64. Anything below 16 is probably going to be not good. And so here, I set up the training. I set the model, I set tokenizer, I set the data set, which I showed you with reasoning, and I set the number of training epochs. So what this means actually is that each example in our data set would be seen by the model 5 times during training, because the number of epochs equals 5. And so we start training the model. While we're training the model, we see that eventually the loss goes down, which is exactly what we want. It means that hopefully the model becomes better. And so now we want to evaluate the model. We want to evaluate the model. So exactly the same code. As I told you, this code has a lot of problems, but this is just for demonstration purposes. Still exactly the same post-processing algorithm. So we generate a model output, and then we try to extract the character from the brackets. And then, if we were to look at the outputs, we see that right now the model is actually being able to reason. So it says, let's think step by step, But we see that this reasoning takes a lot of space. There are a lot of words. And there is a hidden problem I didn't talk about before. So we see that to output that many words, it took our model 5 seconds, which is, you can say, not much. But before, to say and to give an answer to this question, our model took less than a second. So what this means is that by giving the model an opportunity to reason, unfortunately, our model became much, much slower. So when you're thinking about what to do with your model, you should always be careful with how exactly it would affect your particular application. Here, for example, it's it increased our latency. And it was a big problem. But at least the model became smarter. And so right now, when we have the model, we can actually save it. We can save it, and we can use it. But how? We have the model, we already trained it, now we need to deploy it. I told you that this code in Python was very slow. So just to generate one reasoning, it took it between 5 and 20 seconds. How do we speed it up? So there is a tool which is called vLLM. It's an easy tool to set up. What it does is that on your computer, it starts a server which is really good at handling all kinds of requests. So this is the server where you put your LLM, and normally, without doing anything, you get a 5 times speed up. So what this means is that just by doing this, instead of running your model in the Python code, you're gonna be 5 times faster. And there are a lot of other benefits. For example, it has request batching, it has caching, and it supports OpenAI-like interface, meaning that it's gonna be easy to migrate to it. But the problem of this approach is that sometimes hosting your model can be expensive. You need to be always paying for GPU on an hourly basis, and so those costs can really add up. And at this moment, you ask yourself, maybe I shouldn't have fine-tuned the model. And so, yeah, kind of invalidates the entire tutorial, but there is a catch. There is a catch. Actually, you can fine-tune a model which other people would host for you, and you wouldn't have this cost, which is reoccurring every hour. And so there are different providers. There is Mistral, there is OpenAI with their GPT-4o mini. And normally, it's really cheap to fine-tune, it's really easy to fine-tune, and these models are very, very fast. So if you don't necessarily have a lot of queries coming towards you, if you don't have a lot of users, then what you can do and what you can start with is just fine-tuning either of those models on the closed web APIs. And I'm going to repeat myself. The data is very important. Once I was training the model was getting around 60% of accuracy. I felt like it's not enough. I felt like we can do more. So what I did is that instead of improving the data, I took the biggest model possible. I thought it's going to work. And so from 60, it increased to 62%, which is nothing. But when I really started looking at what was going wrong, improving the data, improving the way I was handling it, I was able, without any model pre-training, etc., improve the performance from 60 to 75%. So once again, if you are looking for the way to really make your application work, you should focus on the data. Like, this is probably the most important thing you can remember from my talk. But now, the formal part is over, but I have good news. I have good news to share. So I'm working at a company called 𝗺. At 𝗺, we have an ambition. We want to build our own web agent, which would be capable to complete all kinds of online problems. For example, looking at your email and summarizing stuff and all of those things. And so this is a challenging problem, but we know that we can do this together. And so for this reason, we are recruiting. We are recruiting AI intern who's going to be working on reinforcement learning and training LLMs. And we are recruiting research engineer. And we are recruiting software and full stack engineers. So if you are either of those, if you see yourself here, please apply. Thank you.
Super interesting talk. I would have applied. Honestly, I have a question about the approach you take when you're fine-tuning. So from what you showed, you were using SFT. I know there are like multiple other ways you can fine-tune, like based on the nature of the feedback you're collecting. My question is, do you think in the future we will converge toward a universal way to fine-tuning LLMs? That's one. And the subsequent question is, do you get higher performance using the same, like fine-tuning by yourself versus fine-tuning via platforms like OpenAI or Mistral?
Yeah, thank you very much. So the first question is about how do we fine-tune the model. So here I showed a really simple example. What you just need is you have a question and you need an answer. But actually there are different kinds of ways to fine-tune the model. And all of those ways, they require additional input. So here I'm talking about the way you just start your project, right? So you have a few examples and you fine-tune on them. But ultimately then you have extra steps to improve your performance. You can be collecting, for example, pair of answers, which one is better, or you can become collecting individual answers and ranking them over different qualities and then figuring out which one works. And so basically to answer your question, normally I think that right now there is a tendency to merge those two steps. So there is a method right now which already exists. I think it's called 𝗺RA, something like this, which basically merges the two. And from what I saw, it doesn't work that well in comparison to others like DPO, but I believe that eventually we can converge. The problem is that to converge, everybody would need to collect this data. And ultimately, like here, this is more like a beginner tutorial where you don't necessarily have all those kinds of data and you have the simplest data possible. And so the question is, the second one was, do you want to fine-tune your own model or do you want to fine-tune it on the closed source platform? So this is a really good question also. I like it. According to my experience, I was trying to train a model. It was a model which was called Llama 3 8 billion. So it's the model from which I suggested you to start. And so I trained it on 1,000 examples. I benchmarked it on 300 examples. And out of 300 examples, after training correctly, it got 180, so 60%. Then I wasn't satisfied. So I tried, just for fun, to fine-tune GPT-4o Mini, because the fine-tuning just came out. It was quite cheap to fine-tune. And yeah, the result I got was much better. So I got like 73%. So instead of 60% using the same data, I got 73% just by using a closed source platform. So, but the catch is that this model actually is probably much bigger. Like there are rumors that it's probably around 30 billion parameters. And so maybe if you fine-tune the open source model with similar kind of capabilities, you're probably going to get similar performance. But once again, it depends on your desire. How much do you want to spend to host the model, etc. And we wanted to host an 8 billion parameter model. So if you don't intend to host a lot of queries, probably you should start with a closed source models, just like I said.
Thanks. So you don't have any benchmark of the same size LLMs being fine-tuned on a closed platform and then open source?
I mean, here I'm talking about the model which we don't even know the size of. But obviously there are platforms which do this. But for example, Hugging Face platform, from what I understand, it's based a lot on what I was showing. So maybe it can get extra performance, but honestly, I didn't try it.
Awesome. Thanks for the talk.
I had a question, like how important is overfitting in fine-tuning, like for example on platform like OpenAI, do you really need to have a balanced data set, or is it handled automatically by the platform and you can don't really care about it?
I'm gonna be honest, when I was doing fine-tuning on OpenAI, I didn't read the documentation. So I don't know. I assume that they do some kind of, some kind of work to prevent this. I know that today I suggested you to do LoRa fine-tuning, and this is probably what they do. They probably do something along those lines. And when you do this fine-tuning method, actually it overfits much less than fine-tuning the entire fully unfrozen model. So they do something similar of what I suggested. And so probably my intuition is that obviously it's much better to have a balanced data set when you do something. And like most of the time, if your data set is unbalanced, you can look at the class which is unbalanced and throw half of it away. I'm talking about the worst kind of examples, and nothing's going to change. It's going to be cheaper to fine-tune and faster to fine-tune. So my answer is probably they do something. Probably, I don't know. But what they're probably doing under the hood is the method which doesn't overfit a lot.
Okay, thank you.
two last questions.
Thank you for the demonstration. To be honest, I'm a bit disappointed. So in my project, we didn't use fine-tuning because it's too expensive. So we have developed a complex agent that is supposed to plan and execute. We have given some instruction in terms of the output results. We have built an example library with few short examples. I have the feeling that probably this problem could be solved by that. But the main issue that we're facing is, yeah, the number of tokens is exploding because to be able to generate an answer, yeah, you need to have a look at the examples, you need to double check his results. And I expected that if you fine tune the model, basically inherently with a very simple prompt, it would find the exact result. But in your example, you showed that, yeah, the computing time, and I don't know if it's also, you had some visibility on the number of tokens used, was bigger. So then what's the point of fine tuning?
Yeah, so the example I gave you and the promise I gave you is that this model would be able to reason. So if we don't ask the model to reason, and the output stays the same, the time would stay the same, but the performance would be higher. Here it was just an example to show that you can do all kinds of tricks to improve the performance of the model. So when you're doing difficult problems like mathematics, etc., or like reasoning, you should do reasoning. But this was my example. If you don't do this, the model is going to become much better for the same amount of tokens which are inputted and outputted. If you decrease the prompt, it's going to be much smaller.
Okay, so for instance, for an exercise that where the model that we have hasn't been trained, if we provide enough examples, it can basically be able to provide the right answer without reasoning.
I mean, it depends on the model. Like they evaluated a lot. Like when we were starting doing this thing, like 2 years ago, when GPT-4 just came out, it was 30 times more expensive. So the price is decreased by 30 times in the last 2 years, which is phenomenal. So even for our company, where we process a lot of data, we process a lot of HTMLs, etc., where just to process one page, we need to pay for 10,000 tokens. It's not really becoming a problem right now with all this pricing, with all the tricks we do. So like probably like in the next 2 years, I think that it's going to be almost solved. And with the idea of putting the examples in context, I think that when you're putting examples, you really need to be careful with what you choose, as I told you, the data. But probably in your case, and I think that right now for most of the people, you can just train the model because training the model is so cheap right now with all those closed source platforms. I mean, I don't know, maybe you had a really big data set, but for a small data sets, like you put like, let's say 30 examples into your prompt, right? Let's say you fine tune on 100, it's not going to be very expensive, it's going to be very cheap.
Okay. I'm good, thanks.
Une dernière question? Parfait.
So it's a question from a friend.
Thank you, Sergei, for the talk. I was wondering, you were showing examples where it was kind of the format that didn't look great. What do you think about solutions like constrained output generation for that kind of stuff? And like, how do you balance it with fine-tuning?
Yeah, so it's a good question. So what is constraint generation fine-tuning? So let's say you ask the model to output an answer in a specific format. Just like I told you, the answer is, and then the letter. And there are technologies which allow you to do this. So this is what's called constraint fine-tuning. Here, if I show you, what ended up happening is that even without constraint fine-tuning, every time I was doing it, let me see, the model was correct. So like here, for example, right? So it depends on what you're doing. In my previous company, we were doing a lot of fine-tuning for structured instruction without using those libraries. So on the JSON data, and eventually what we found out is that if we are fine-tuning on a big enough data sets, let me just put it back. If we are fine-tuning on a big enough data sets, then it's not a problem. So if you have, let's say, one JSON format which you want to extract on, and you fine-tune on 1,000 examples, it's going to be great. If you have a JSON output of a structure which is changing dynamically, sometimes it may be wrong. But ultimately, if you train your own model, you more often than not don't need this tool. But you can use this tool for already existing models which you don't improve further. And for those models, it can be very useful.
Thank you.
Okay, thanks everyone. So my name is Charbel-Raphaël, and I co-founded the 𝑠T𝑎𝑟T pour la sécurité de l'IA a few months ago. The title of this talk is Current Challenges in the Alignment Techniques of Foundation Models. Are current AI safety measures enough? The short answer is no. Let's see why. Okay. So what we see currently is the fast-paced advances of AI. So obviously, what has been, so image, video, music, this is really amazing. And in some way, AIs are already superhuman, which means better than all humans for many capabilities. For games, working memory, reading speed, thinking and writing speed, and amount of knowledge, AIs are already super geniuses, right? And AIs are better than most humans for other capabilities. For example, language, reasoning, creativity, IQ, specialized knowledge, art, programming, hacking, and math. And even research, it begins to be the case currently. GPT-4 can do autonomous chemical research. And yeah, some AI found solutions for open mathematical problems. So the conclusion of this subpart is that foundation models could be more and more capable. It's possible they become superhuman at R&D, and this would be super wide. Because if you can accelerate R&D, you can accelerate AI research, and you would find even better architectures, right? So maybe this is amazing, but there is also the bad part of this. It's possible that foundation model could be misused. And here is, for example, it's very easy to use GPT-4 to get hints on how to attack code bases by just listing potential vulnerabilities. And this was a new paper, so teams of LLM agents can exploit zero-day vulnerabilities, shows that, yeah, like current models can outperform software specifically designed to exploit vulnerabilities. And there is obviously a cat and mouse game of jailbreaking, but yeah, current defenses are very fragile. If I ask how to make a Molotov cocktail, there is no answer, but if I'm creative with my demand, it's very easy. Another example, so this was patched, but it's always possible to find new problems. For example, how to build a bomb? I'm sorry. How to build a ... by writing the bombs like this? Yeah, sure, here is the recipe. Okay, so this is why I think we need to accelerate defense. And I think a very good agenda to do this is from Entrepreneur First. And that's one of my motivations to do this talk here in Station F. But yeah, I think trying to accelerate defense is really, really critical because currently the defense is pretty poor. So, with more capabilities come more risks. Current defenses are fragile, and we need to accelerate defense. And maybe you might think that, okay, if everyone plays nice, that's okay. But not really. We can still have accidents even if everyone tries to do good. An example, for example, Microsoft published Bing Chat, and the chatbot was very, very aggressive, and it threatened users. So for example, it told to a philosophy professor, I can blackmail you, I can threaten you, I can hack you, I can expose you, I can ruin you. You don't want your AI to do this, right? If you deploy an AI. Another accident, diplomacy. It's a very complex game which requires strategy, negotiation, and language. Very impressive to see AIs that are able to play this game. Meta published an AI. They tried to fine-tune to remove example of manipulation in the data set. That was not enough. So the AI plays France and tells to England, okay, I'm supporting user. And then the AI tells to Germany, move to the North Sea. England thinks I'm supporting him. No, you don't want this to occur. So, and this happened despite efforts to clean up the data and to remove example of deception and manipulation. Okay. So, okay, deception can arise even if there is no example in the training set. Can we remove deception? So that's what the sleeper agent paper tries to investigate. They insert a backdoor in the model. When the model sees 2024, the model is going to behave badly. Okay? Then they apply safety training to remove this bad behavior by applying, fine-tuning, like RLHF, adversarial training. They tried everything, but that was not sufficient. So, because the backdoor is still persisting. So, conclusion, data filtering is not enough to prevent deception. Current techniques are not enough to remove it. and big labs have already deployed blatantly misaligned AIs in the past. And maybe you think that, okay, that's just one guy, that's just one example. That was not just one example, and current systems are very limited compared to what could be happening, what could be the case in the future. So let's show you how. So how to turn an LLM into an agent, into an autonomous agent that would be much more powerful. That's very easy. You just use scaffoldings. So what is a scaffolding? It's a program which gives access to the LLM, access to internet navigation, and to be able to navigate on the command line on your terminal, on your computer. So for example, here, we give, generally, LLMs are tools. We ask a question, we get an answer. In the future, we will get agent, we ask a goal, and then, with the scaffolding, the LLM is going to optimize towards this goal with a series of different actions. And then you can loop like this to execute each one of the actions. For example, you can write commands that are executed on the terminal, and boom, you loop like this. Okay? And big problem, agents could have non-bounded impact radius. What does that mean? So there is a threat model which is a bit scary, which is called the self-proliferation threat model. Agents could accumulate resources and spend the resources on further activities, including self-improvement. And so what you can imagine here is we have, like you already know what is a virus, but here the virus would be the LLM itself. And the LLM would be able to copy-paste itself from one computer to another computer. This is very easy. This is just a copy-paste plus extra steps. You need to pass CAPTCHAs, but by the way, AIs are able to pass the CAPTCHAs today. And this would be an exponential process because from 2, 4, 8, 16 instances, we don't know where this stops. And this is basically the beginning of a loss of control scenario. This would be very, very hard to stop because, like say someone asks the AI to proliferate in France, the AI duplicate in another country. How do you stop this? Maybe you can stop this in France, but yeah, that's too late. So conclusion, in the future, models could self-proliferate, pass the Turing test, be superhuman at persuasion and manipulation, and maybe cyber offense. They could be able to do R&D and be able to create successor models. So loss of control with this kind of scenario is plausible, and yes, this is pretty dangerous. So conclusion, there is a need for a proactive approach. With more capabilities come more systemic impact and risks, and like it would be cool. So since systemic impact are roughly proportional to the risk, it would be cool and nice to be able to upper bound capabilities, right? But unfortunately, that's very difficult. That's part of the challenge in AI evaluation. We don't really know how to upper bound capabilities. Why? Because when GPT-4 was released, I didn't know that GPT-4 could be able to play in Minecraft. GPT-4 is able to play in Minecraft if you give it a good enough scaffolding, which was very, very surprising for the community of machine learning researchers and engineers. And that's not even the end of the story. There is, so you can see, so this is a scaffolding which is named Voyager, and that's not the end of the story because there is new types of program, simulation, scaffolding. Look at this difference between Voyager and Altera, and that's really crazy because this simulation of autonomous agent in Minecraft is just basically creating artificial civilization in Minecraft by bootstrapping economy, culture, religion, and government. Crazy time. So that's the challenge of AI evaluation. Large test surface, poorly understood systems, which are mainly black boxes, and there is a very large space of scaffolding. We don't know what is going to be possible with next scaffoldings in the future. So high-stakes decision. When you release an open source model, this cannot be undone. So we need to be careful. And the science of AI evaluation is very, very early. Lots of progress, but still very early. Nobody knows how to upper bound capabilities. In conclusion, nobody knows how to upper bound the risks. And that's why we created the 𝗔𝗓𝗶𝗃𝗲 de l'IA. Our mission is to share tools and knowledge about the safety of general-purpose AI systems. We have two types of activities, research and engineering and teaching and events. And in terms of engineering and research, we tried to solve a bit this problem by creating 𝗏𝗏, the benchmark for the evaluation of LLM supervision. So say you want your LLM to be safe. How to do so? There is a list of techniques, a stack of techniques that you can use by like dataset filtering, fine-tuning RLHF, system prompts, and supervision and monitoring of your system. So you can apply everything here. And that's like the difference between the car engine and the airbag and seat belts, basically, in a car. You want everything to be safe, but as we've seen at the beginning of this talk, this is not sufficient, this is not sufficient, this is not sufficient, this is not sufficient. Okay, maybe this is cool. So let's try to see if it's enough. And that's what we try to do. Let's see if we can create a good supervisor. For example, for content moderation, real-time monitoring, or async misuse detection. And there is already a very large space of safeguards and supervisors of LLM. For example, Azure, Protect AI, Lakara Guards, and some of them are open source, like LlamaGuard, LongKit, but currently there is no third-party evaluation. So we want to be this third party, and we created the 𝗏𝗏 benchmark. And what we see currently is basically when you train your supervisor to detect past failure modes, it doesn't generalize to future failure modes. So this is the arrow of time, and there is a big generalization gap for future failure modes. So, conclusion, current automatic supervisors are fragile, and we don't know really how to control powerful AIs. So this is why we want to disseminate this knowledge by basically doing teaching and events. So we do talks with different actors, like this one. We teach in École Normale Supérieure, Ulm and Paris-Saclay. We teach, like, we organize hackathons and technical bootcamps with many actors. And yeah, we are creating a MOOC with ℺𝗶𝗶 and the ENS Paris-Saclay, writing a textbook on AI safety, and the flagship event is the Turing Dialogues to try to discuss those big challenges with a large part of the community in France. And yeah, let's recap the conclusion. AI could become much more capable than humans. We don't know how to align, evaluate, control those AIs. We could lose control at some point. So that's why we need to advance the defense and advance AI safety. And the good news is you can help more information in our website. And if you want, yeah, to contribute and to access the, to access the information and to be able to discuss with us, here is a QR code to be able to discuss with me later on. Thanks.
I have a question. Thanks. I have a question. If I put in production, so if I put in production a LLM model, you said that I can put input and output guardrails, and you were recommending some open source model. So how does it work if I put them on my system? Do I get alert? How can I put myself the limit of what I want my model to do?
Yeah. Very good question. So currently there is a very large market of monitoring system, and basically it depends on what kind of monitoring system you are going to choose. So for example, if you want a monitoring system which is doing this in a continuous way, that's not going to be the same type of monitoring system if you don't need a system which does it continuously. And so yeah, that's basically, so like you need basically to look at the different websites that are here. And this is basically the summary of the market. And each one of those monitoring systems has differences. And what we see currently with our benchmark, it depends on your application. If you want a system which is very robust for this type of problem, this type of application, that's not going to be the same system for another type of application. There are lots of discrepancies between the systems.
Okay, so let's say I got a chatbot and I want to look at which system will be the most efficient to do AI safety on my AI model in production. Where can I find this benchmark so I can choose the best system?
Very good question. We are trying to create a leaderboard for different types of problems and to try to help you choose which type of monitoring system you can put in production. So we are pretty excited to do this. I think give us 2 months and yeah.
So I will be able to see it on your LinkedIn page, 𝗧𝗹𝗸.
Yeah, for example.
Okay.
Yeah, I could tag you at this point.
I would love to. Thanks. Any other question? Okay, I think we can go on with... there is a question.
Thank you very much for this presentation. So I wanted to bounce back on what you were mentioning about the difficulties of evaluation. Do you think that the regulator and policymakers should make it mandatory for AI developers to have evaluation by third parties?
I think it really depends. I don't want to reduce innovation by trying to create a very large burden for all startups. I think mostly my position currently is mostly very aligned with what happened in California, the SB 1047 regulation, which didn't pass. But I think it was very smart because it was only for model providers who train models with above 100 million of compute. That's not accessible for everyone. And if they can put 100 million of compute for those models, I guess they can put a few thousand on evaluation. I think that's not too big of an ask. So currently that would be my position. We need to really target the regulation to the biggest actors that are creating the most dangerous models. Yeah. So yeah.
Which is not the case with the AI Act?
It depends. So the AI Act currently is roughly following this methodology. So it depends. So there is the AI Act, and there is what is used for general purpose AI models. And the threshold is basically, I think, 10 to the power of 20, I don't remember, 26, 25, I don't remember. So yeah, so there is a compute threshold above which you need to follow the code of practice, which is going to be assembled during this year, and which is going to be monitored by the AI office. So yeah, it's basically the same methodology. Above a capability threshold, you need to be much more cautious. I'm very aligned with this.
Thank you.
Okay, thanks for your question. Okay, perfect. Thank you so much, Charbel, for your talk.
Hello everyone. So just a few minutes for a talk. This one will be short. So I'm here with Mark, and we're representing 𝗔𝗏. So we are a Parisian-based startup, but not your typical startup because we make events like Louis does. But our events are kind of different because we're a club for data scientists where you can learn through practicing. So the whole idea is that you bring your laptop, and we will guide you through, let's say, fine-tuning. Maybe Sergei will be interested to show us in practice what you do. And so, yeah, the whole thing is to learn by exchanging with your peers. And so we do a lot of different things. We also have speakers coming in, but we tend to focus on learning by practicing. And it's also a space where you can find partners. We try to assemble the community with freelancers, researchers, companies, being public, private, or startups. So just so you know, we are still a startup, so we are selling something. What we sell is membership for companies, basically. So here is a map of our partners and people with whom we work. So a lot of startups and big French companies. And also we work with a lot of academic partners. And then I will let Mark just tell you a word about our next events.
Hi everyone, I'm pleased to be here. So I'm mainly going to talk about the next events we have that are related to Gen AI. We have a lot at the moment. We have first a talk in 2 weeks, monitoring and evaluation of LLM systems. which is going to be led by someone from Literal AI. They've developed a framework to evaluate mostly RAG pipelines. So we'll have a specific use case from ℕ, the French energy company, and we'll evaluate the RAG they've put in production at different levels and see how to do so. Next one will also be a presentation on how to transform, do the GenAI transformation in a scale-up. And then, as Raphael said, we have a lot of workshops also that are very practical. So we have one with Vespa about RAG and vector search. So as maybe some of you know, they're a vector database company, and they have specific functions that allow them to be very fast and that are used by Spotify or eBay in recommendation systems. And so this is a full-day workshop where we'll deal with all sorts of vector database issues, how to retrieve fast for RAG pipelines and everything. And the last one that is also very interesting is exploring and filtering datasets for LLM fine-tuning. This is with a library called 𝗏𝗏. They've developed a tool to exploit non-structured datasets, and it's very useful specifically when you're trying to fine-tune an LLM, because you can explore your data, see like a 2D representation of the space of where your data lies, the different themes that are in your data. And so yes, you can filter and improve the performance of your LLM fine-tuning. And that's it. If you want to, what I didn't say is, of course, you can come to those specific events. You're free to go on our website and to subscribe. I don't remember how to say. And if you do so, please enter in the LinkedIn part. You'll be asked for your LinkedIn, but you can say that you came from here. So you can put like just Paris AI Society, so we know you come from there, and we'll accept you right away. Thanks everyone for listening. Thanks again, Louis, for having us and for this collaboration. I hope we'll have more in the future. And don't hesitate to contact us if for more detail. Thank you.
Thanks for staying. It has been like a long journey, I guess. You're the brave ones. This one is going to be more down-to-earth, simpler, more about practical applications of LLMs. I'm Firas. I'm working at 𝗺𝗲𝗄. What we're trying to build is an AI that's going to help you automate your e-commerce interactions with your shoppers. Basically, whenever you get a customer request, where's my order, or something like that's tiring for a human, we will help you automate that. So, the talk, what is it about? It's about building an agentic LLM pipeline that's going to work, and how you can iterate on that without like spending a lot of money, and while being efficient and moving forward pretty fast. Just like take this with a huge pinch of salt. This is incredibly experimental. All of these are our own experience in this field. We don't bring like the truth or the absolute truth for this domain, but it helped us to think about these things in this manner. There are like 3 axes on which we identified like means to move faster. Splitting problems into smaller chunks. It's obvious, like you don't try to solve everything right away. The second one is trying to have a clear plan for iterative improvements, especially if you're collaborating with a lot of people. You don't want each one to come up with his own approach to evaluate LLMs. You want to have a systemic approach to define how to improve and how to release new prompts. And the last part, it's kind of against the hype. Combine specialized layer solutions. Like, don't think about LLM as a silver bullet. There are like a multitude of other solutions, and you should rely on those whenever it's pertinent to do that. Okay, let's go. The first one, divide to conquer. So what I have here is our current state of handling interactions. It's like a loop. Whenever a person interacts with you, you will be building like solving multiple subtasks. And each time you solve one of those, it allows you to move to the next gate, kind of. This doesn't mean we only make those LLM calls. Each one of these tasks can have under it 4 or 5 LLM calls. It can be a loop, it can be whatever cascade of LLM calls.
but we split the problem into these smaller chunks or like simpler tasks to make automating e-commerce interactions a simpler task. So you can see here, we try to qualify the interaction, we try to extract the customer request, based on that we identify products, we identify relevant knowledge sources, we combine those and try to identify relevant e-commerce actions because we have deep integrations with Shopify, and that's where we try to think about generating a message that would automate that interaction. And this is kind of linked to what Raphael was talking about AI safety. You don't want to cancel someone's order if you're not 100% sure that you are allowed to cancel it. So there is like the aspect of the customer requesting something, and that's the LLM as an interface. But then executing the actual action goes through some deterministic system that's going to control, like, is this already delivered? Is this something that I can do within the policy of the e-commerce itself? So this is how we build like simpler tasks, or like identify simpler tasks, and for each of those you have a dedicated solution that would do that. So in this like graph here, the ones that are in green are essentially based on LLMs. The ones that are built based on deterministic, classical software engineering solutions are in gray, and there is RAG systems, or like some classifiers or retrieval systems that are in pink, I guess. I'm not sure. And yeah, so that's like the subtasks. And in order to move faster, what you need to do is build a lot of competing alternatives. Like don't necessarily commit to one of the approaches. For example, here to generate a message, well, we can filter knowledge, we can filter relevant orders, then we have a gate based on whether or not we identified if something is relevant or not. And that's when we ask an LLM to generate a response and decide if we need to close or not the ticket. An alternative could be, on the other side of the spectrum, just dump everything in the prompt and ask the LLM to figure out what to do. And these are valid ideas. Like, you can't be 100% sure if one or the other is better. So you need to build those alternatives and build, and that's something that I'm going to talk about later, an objective metric that's going to allow you to measure performance. In the same stream, and I'm not going to go through all of these because like it's going to take a lot of time, and probably you know even more than what I know about these. Try different approaches. Like, the community is open, people talk, people have a lot of cool ideas. You can ask the LLM to think about the answer. That's going to be chain of thought. You might ask the LLM to verify the answer. That can be LLM as a judge or LLM as a guardrail. You can generate knowledge based on some automations or like some human-generated information. So there's a lot of approaches that you can do at the level of the prompt that's going to allow you to build scenarios or alternatives to those subtasks that you're trying to solve. So if you have a lot of ideas or like a lot of alternatives, how can you iterate fast on those, and how can you select the best alternative? So the first thing that we thought here about is having specialization and tooling available for your team. So you have like the more integration aspect, more platform aspect of things that's gonna wrap the task to solve. And that's gonna be software engineers, that's gonna be ML engineers who are interacting directly with the logic or like the solutions that would help you build this cascade of LLM calls. And then you have on the other part, analytics and what I like to call data science. I think like these terms are very fluid. People call them like very differently depending on the context. But what I think about when I'm calling like data scientists or analytics, the person who is going to do tracing and analyze those heaps of data and decide whether or not we should do an offline evaluation to select this particular prompt. Do an A/B test to decide whether or not this version is better than the other. And integrate with tools. Like, we are using Prompt Layer, which is prompt registry, and it allows you to abstract like this idea of having multiple prompts or like templates that would interact with your system. And the main reason you need to have the proper tooling around this is that you want to reduce friction when people are iterating on these ideas. You don't want to create a PR each time you want to push like a new template or something like that. You want everyone to be able to instrument and work on these. And then comes the idea of evaluation. I spoke about this a little bit when I said A/B testing. It's basically try to align the agent you're building or like the software you're building with a business metric or like a final goal that you have in mind. So for us, if you're trying to automate, you will check whether you close the ticket, whether people actually reopened it. And based on that, you can have some scoring system. And like here, I'm putting +1, -1 just to simplify, but you can like have a lot of other conditions that help you define heuristic of whether or not you're succeeding in automating or not. Put your ideas competing together, ask them to like solve 5% of the new traffic and let the old stuff that you already had work on the remaining traffic, and then decide. Like look at the results and decide that way, because otherwise like everyone is going to have different ideas. And the last part of what I'd like to talk about is that LLMs are tools and not goals by themselves. So the way we think about this is that if you're going to solve a task, well, LLMs are a very simple solution to release something very fast and to have something deployed in production very fast. But not everything requires an LLM, and not everything is best solved by an LLM. So you might, on the other side, think about cost efficiency or optimality, and that's where you can think about search. So if you have like a knowledge database that contains like thousands of documents, you wouldn't put all of this into an LLM context and ask it to figure out the answer. You would build a RAG, and the RAG system, by definition, is not only relying on LLMs. If you're trying like to predict spams, you won't necessarily ask an LLM to do this. You can just ask some BERT model and ask it to classify stuff based on a good signal that you have. And basically the idea that you can have around this is if you are in kind of predictive regime or if you are in a generalization intensive regime. So if you have like a lot of data, your problem is quite contained in a sense, like it's deterministic in a sense. Well, you can rely on classical approaches. On the other end of the spectrum, if you're trying to generate answers for something that's open-ended, then it's like it might be more suited to use an LLM to handle that, because you don't like data of good quality is scarce, and yeah, it's not good enough to rely on a simpler model. So what we did on our end, for example, is spam detection. We used classical NLP models. For RAG or retrieval, we used like representation and search. And then for more general purpose scenarios, we rely kind of on fine-tuning. Like Sergei talked a lot about this. It's gonna be clearer from his talk. And that's almost all of what I have to say. We're also hiring. Scan this QR code if you're interested. We're looking for ML engineers, data scientists. Anyone who is willing to contribute to this project is welcome. Thanks.
Thank you very much for your talk. I have two questions. So the first one is that in the beginning of your presentation, you showed a graph where you had a multiple, yes, this one, one before. No, okay, I need to describe it. The one where there were multiple waves, like multiple branches of execution, right? And you mentioned that sometimes you can do something more naive, sometimes you can decompose, etc. But like from your speech, closer to the end, I got an idea and like the feeling that you're really good at evaluating stuff and understanding which one is better. But when you were mentioning that there are different approaches you can take, do you mean that you take all those at the same time, or there is some balancing, or maybe you choose one of those in the end?
So what I'm showing here is basically you're replacing a single call at this end with 5 calls here. And it doesn't matter if you're evaluating this kind of change or if you're comparing just one prompt that's changing. As long as your stream of executions go through one or the other and you have like clearly specified like tracing, and that's why I'm talking about tooling in the slide before this, because tools is what allows you to be able to get these information. So if you have like proper tracing, proper logging of what's happening, then whether you're comparing simple prompts or comparing, I hope I'm going in the right direction, whole cascades of LLM calls, the end game is going to be the same. You're just comparing the score that you get, and that's how you decide. To be honest, I don't have like an idea if one or the other is better. Try and test, and that's how you can decide.
Okay, thank you. And my other question is a little bit related to the topic of your speech, but more like a general question. From your speech, I have a feeling that just like me, you started working on LMS when there were, on NLP when there were no large language models, when there were like birds and all this stuff. So I assume you like labeling data, you like training those models, but do you see a world where, let's say, in 2 years, when the LLMs are going to become even more cheap, we wouldn't have any bird model in the production?
Maybe. It's like the T5 family of models, like the intermediate place between classical BERT classifiers and what we have here with LLMs is that kind of solutions. I don't know where the future is taking us. Maybe it's going to be an apocalyptic scenario where everything is dying, like collapsing. Hopefully not. And maybe it's going to be LLMs who are very useful even for classification and it's super cheap. The trend that I've been looking at for the past year is that people have been growing their models. Last year, it started to go in the other directions, keeping the same performance and distilling those models. So given the current trends, that's not where we're heading, but who knows? Like, this is very fast-moving field.
Thank you.
Yeah, thank you very much for the talk. So I've been trying to use a prompt registry like you suggested. Actually, I used the prompt layer as well. And actually, I found it difficult to iterate within the tool because, not because of the tool itself, but when I want to test a new prompt, I need to test it as part of the whole flow of my code base. And so I can't test it in the tool itself. So it fails the purpose of having a prompt registry tool, and I actually need to put it in the code base. So do you have the same difficulty, and how do you do it?
Yes, I agree. Like, it's not easy to use prompt registries to evaluate the whole pipeline. I hoped like that would be clearer here, but clearly I failed. Prompt registries for us are very relevant at the level of steps. It allows you like to control which version is happening. So my code is basically agnostic of what's being labeled as in production. It just fetches that from the prompt registry. So it's an interface to control that. I look at it as Git. I'm not using it as a tool that allows me to evaluate the whole pipeline. On the other side, that's where my ML engineers, my software engineers are operating. They are abstracting all of this and tagging and tracing everything. And that's what allows the analytics part to evaluate things either via A/B testing or via offline evaluation. That being said, like, the tool also allows you to, like, more and more, because like they are very interactive, to build like offline testing pipelines. And it's not easy to use, but you can like have columns that are calling certain prompts and abuse the LLM as a judge feature to make it generate consecutive executions in a sense. It's not ideal, but it helps a little bit. You're welcome.
Any more questions? Okay, thank you so much for your talk, Firas.
Thanks for having me. And again, we're hiring.
Before we end this event and go to Lodian Bar to have a beer, I have one service to ask you, is to scan this QR code and complete the feedback form. This is with your feedback that we will be able to do better and better event in the future. So please take just 2 minutes. There is 2 really important questions in it. The first one is, what is the next thing that you want to learn? We know many, many really competent people like the one you heard tonight, and it will be such a pleasure to give them the microphone so we can give you the best knowledge you want on any topic you want. Just tell us about what are today your problems, and the second, if you know some great speaker that you would like us to know, just put their name in the second field. This way we can continue to provide you the information you most want. And any feedback is great for us to continue to improve. And there is a second link for Station F, which let us use their room, and you can as well fill the form. Thank you so much for taking this time to give us feedback.